Alright, so in this section, this is section 5.2, and now we're going to actually see the practical application of all that stuff we did in 5.1. So in 5.1, you were probably wondering, what is area to the left, area to the right? That's great. I know how to do it using normal CDF, but what does it have to do with real life? And so here's the answer. First thing I want to mention is that you can do these problems when you're doing normal CDF. You might remember from the last section that the way it works is you put the lower right here, the lower boundary, put the upper boundary here, and then here you put mu and sigma, and you can either, usually we were doing 0 and 1 when we were doing z-scores, but remember 0 and 1, that's how it works on a standard normal distribution. Okay, you don't always have to use a standard normal, you could just use a regular normal, which means you haven't yet converted these to z-scores, and you'll get the same area. So this is a good picture right here. Suppose that the average test score is 500 and the deviation is 100, because you can see we're going 100 either direction to get from 500 to those numbers. If they said find the area to the left of 600, that would actually be the same as saying find the area to the left of z equals 1, of 1 standard deviation. These areas will be the exact same. That's what this long paragraph is saying. Alright, so let's do a couple examples so that you could change all of these values to z-scores, but I'm going to show you kind of an easier way to do it. It's more direct, and you don't have to do it that way. Just one slight caveat in the calculator. So a survey shows that people keep their cell phone an average of 1.5 years. Okay, so I'm going to put 1.5 in the middle. Now remember, you might say, how come we're not putting 0 in the middle? Because that would be if we change 1.5 to a z-score. If you tried to do this formula right here on 1.5, you would get 0 right here. But we're going to do it without changing it because you don't have to do it that way. This is probably a little bit easier. The standard deviation is 0.25 years, so that's sigma. So I'm going to add 0.25 to 1.5, and I'm going to subtract 0.25 from 1.5. Okay, and these are one standard deviation more or less. If you were doing z-scores, that would be a z-score of -1, that would be a z-score of +1, and this one would be 0. Question is, find the probability the user will keep his or her current phone for less than 1 year. So remember, these right here, these numbers are years. We want to know less than 1 year. So 1 is approximately right there. We want to know less than, which means I'm going to shade in the less than zone. So they're asking us, what is that area right there? What is that probability? So here's how we can do this. Go to normal CDF. Okay, and obviously they're telling us we're assuming it's a normal distribution, otherwise we couldn't do this. Go to normal CDF, and let's think about this. We need lower, we need upper, we need mu, and we need sigma. Okay, we've done this before, but this is going to be slightly different because it's a different situation. So first of all, the lower bound is going this way forever, and so remember we can use -10,000. Okay, the upper bound is right here. What is this upper bound? It's 1 year. Okay, I know that's not a z-score, but that's okay because these are not going to be 0 and 1 now. Because we are using these numbers, because we haven't changed to z-scores, that means the following. That means this, remember we used to be putting 0 for mu, now we're going to put 1.5. Because what is 1.5? 1.5 is the average number of years without having changed anything to z-scores. And I want you to think about this. What is sigma going to be? It's not going to be 1, because 1 is what we use with z-scores. It's going to be this number right here. Sigma means standard deviation, so I'm going to put 0.25 right there. So take those numbers, put them in the calculator, and you should get a probability. If you look at that area that we shade, it should be significantly less than 50%. Let's see what it actually turns out to be. And it looks like there's a 2.28% chance. You can see their picture right there. Very small chance that they'll keep their phone for less than 1 year. And that's useful information to know if you are, let's say, a phone company. You're trying to market, a new cell phone plan or something like that. Alright, so I encourage you to try this example in the book. It's a similar sort of example. 67 would be your mu, 3.5 is your sigma, and you want to know what's the chance that somebody's going greater than 70. So here's a rough sketch of that. 67 will be in the middle. 70 is about right here. You're asking for greater than 70. What's the chance of going greater than 70? So you have to figure out, NCDF just as abbreviation for normal CDF, figure out what your lower and upper will be. Your average is going to be 67 and your deviation is 3.5, and try to plug those in, see what you get. Okay, your lower should be this number right here. That's the lower bound, 70, and the upper is way out here. Let's call it 10,000. Okay, when you do plug that in, hopefully you wind up getting a 19.49% probability, okay, which is what that picture shows right there.